Ion dipole interaction. Ion dipole interaction. As we know that polar molecules are attracted towards ions. As we know that polar molecules are attracted towards ions. The negative end of dipole is attracted towards the cation, while the positive end towards the anion. This is can also show M cation, arrow mark of cation and anion. Okay, cation M positive attracts the negative ends of the dipole, whereas anion negative attracts the positive ends of the dipole. This type of interaction is called as ion dipole interaction. It is used to explain the dissociation of NaCl, sodium chloride in water. When sodium chloride is put in water, it dissolves in it. This is because the negative ends of water molecules attracts towards sodium positive ion, and the positive ends attracts towards the chlorine negative ions. Thus NaCl dissolves in H2O due to ion dipole interactions. Characteristics of van der Waals process. Characteristics of van der Waals. Characteristics of van der Waals process. Characteristics of van der Waals process. Okay. Characteristics of van der Waals process. These forces are short range forces. These are only effective up to 10 to the power minus 7 centimeter. First, these forces are short range forces. These forces are short range forces. These forces are short range forces. These are only effective up to. These are only effective up to 10 to the power minus 7 centimeter. Second is, these forces are much weaker. These forces are much weaker. These forces are much weaker than both ionic and covalent bonds. Ionic and covalent bonds. For chlorine, its value is 21 kilojoule per mole. Application. These forces are responsible for the hardness of certain solids. These forces are responsible for the hardness of certain solids. Crystals containing van der Waals forces. Van der Waals forces can easily be broken and will be soft and have low low melting low melting point low melting points. Okay, these forces are responsible for the hardness of certain solids. These forces are responsible for the hardness of certain solids. Crystals containing van der Waals forces can easily be broken and will be soft and have a low melting point. Second is as van der Waals forces are easily broken down, as van der Waals van der Waals forces are easily broken down, hence condensate gas readily vaporizes. Okay, factor affecting van der Waals forces. Next is factor affecting van der Waals forces. Okay, factor affecting van der Waals forces. The magnitude of van der Waals forces depend upon the following factors. First is the number of electrons present in molecules. Okay, the magnitude of these forces increases as the number of electrons in the molecules increase. Consequently, boiling point of the molecules also increase. Second point, molecular mass. Higher the molecular mass of a molecule, the stronger is the van der Waals forces, and thus boiling point also increases. Third point, temperature. Lower will be the temperature, lesser would be random movement of molecules, and greater would be the molecular interactions. Thus, at low temperature, these forces would be relatively stronger. Okay. Fourth is pressure. With increase in pressure, the molecules come closer to each other, thus greater will be attraction. With increase in pressure, the molecules comes closer to each other, thus greater will be attraction. Okay, this chapter is end, and the new chapter is started from the next video is chemical bonding part second. Okay, thank you.